Hey Geometry, it's Mr. Lineski. Today we are going to be looking at surface area. But before we do that, we're going to just talk a little bit about some vocabulary about what exactly is surface area and volume. If you think about the two words, surface and area, we're looking at three-dimensional shapes now. The surface area is just when you add up the area of all the faces or sides of a three-dimensional shape. So it's the total area of the outside of a three-dimensional shape. So that is called surface area. Volume is the amount of space that you fill inside of a figure. So if you had sort of a cylinder of some sorts that you were filling with water, the amount of water that fits in that is the volume. For surface area, we are still talking about an area. So when we talk about units, it's still going to be units squared. When we talk about volume, however, that is now going to be units cubed, so to the power of 3. Okay, so kind of have some basic problems here first we'll talk about together. Then we'll look at a composite figure. So for the first one, we're just looking at a rectangular prism, a box if you will. So surface area formula for that is going to be 2 L times the width, or length times width, plus 2 times length times height, plus 2 times width times height. So when you're looking at a prism, the height is typically the one that is vertical, goes up and down. The width and the length, however, really doesn't matter which one you pick. You could say that this is the length and this is the width. It's really not going to change the problem because all parts are sort of represented equally here. So all we're going to do is just go ahead and substitute these numbers in. Keep in mind, if you want, you can either chunk this off as you're doing it on your calculator, or if you want, you can type it all in as one big thing if you're sort of comfortable with doing that. So when I calculate all of this out, you should get a surface area, total surface area, of 592 centimeters squared. So again, imagine this box is just sort of 6 different rectangles, and you're basically just finding the area of each of those rectangles and then just adding it all together. Our second figure here is a cone. And so for the cone, the formula for that is pi r squared plus pi r L. So L is this sort of new feature that we really haven't talked about with a three-dimensional shape called a slant height. So if you look at your formula sheet, you'll see they kind of mark what L is representing. L represents that slant height. So if I go back and look at this figure, there is no L here, but L technically goes right there. So to calculate L, the height of the cone and the radius of the base, that circle is the base, we're going to do Pythagorean Theorem here. So to figure out what the slant height is, I'll do Pythagorean Theorem. That's going to be 3 squared plus 9 squared equals L squared. When you simplify that out, you end up getting L squared is equal to 90. So I'll just leave this as square root of 90. If you want to write it as a decimal, that's fine too. So now for my formula, I'm just going to kind of fill in the pieces here. So pi is 3.14 times the radius squared. Remember, order of operations, square the radius. Don't multiply by pi first and then square. And then we have pi times the radius times the square root of 90 is our slant height. And so when we go ahead and add all of that together, we should get a total surface area of 117.64 inches squared. So that's our surface area there. So now this one here is a little bit tricky. This figure is known as a triangular prism. If you take a look here, we actually have 2 right triangles and then 3 rectangles that sort of make that prism. The 2 triangles are what are called the base of the figure. So the base of the figure is a triangle. How to determine what the base is you need to find the 2 shapes that are parallel from each other. So notice that these rectangles all kind of intersect with each other and intersect with the triangles, but the 2 triangles never touch each other. So that's how you know what the base is. So the formula for this triangular prism, I'll use a different color here. So the formula for that is going to be surface area equals HP plus 2 big B. And if you take a look at the formula sheet here, they kind of have a little guide down here to indicate what some of these things are referring to. Big B is referring to area of the base. And so we said at the beginning of the problem that the base figure is a triangle. So then we have to go back up to just the 2D shapes and say, okay, well that's 1/2 base times height. So for this, it's going to become 2, and instead of big B there, we can say 2 times 1/2 base times height, because it's a triangle. So now here's where it gets a bit confusing. If you notice we have 2 H's here, the H at the beginning is referring to the height of the prism. So this 22 right here is the height of the prism. If I put the base on the bottom and it stands up tall, this would be the height. So that H is going to be 22 times, and then that P represents perimeter of the base. Once again, the base is a triangle. So to find the perimeter of that triangle, it's going to be 7 plus 24 plus, we don't know what that side is. So once again, Pythagorean Theorem to the rescue. When we calculate that out, we'll just call that x squared. When you calculate this out, you should get that x, oops, not x squared. You should get that x is equal to 25. So we'll put a little 25 there. So now perimeter of the base is basically just saying 7 plus 24 plus 25, which is going to equal 56. So plus 2 times 1/2. So now this is referring to just the triangle. We're done talking about the prism. We're now just talking about this two-dimensional triangle base. And so for that, we need to figure out, well, what's the base and the height? So remember, the base and the height are where the 90-degree angle is met. So that's right here. So we can say that it's 1/2 times the base of 24 times the height of 7. So again, multiply all this together, add it to this. When we do all of that, we should get a surface area of 1,400 meters squared. So the last figure that we're going to look at here is a composite figure. So we can do composite figure surface area problems. Remember, composite is when we either put shapes on top of each other and we add or we subtract. I still recommend that you come up with a game plan for these. So one thing I want to kind of point out and remind you of here is that we are covering this as if we were wrapping it with wrapping paper. So imagine that this were just like a little plastic ice cream cone toy and you were wrapping it. You would not be wrapping this part of the figure, because that's where the hemisphere is, or the half of the sphere. And so we actually don't do the surface area of the cone. We do what's called the lateral area. And if you take a look at your formula sheet, some of these figures you'll notice have volume, LA, SA. If you check your key down here, SA represents surface area. Lateral area is what LA is represented by. Lateral area is when you're finding the area of all the sides except the bases. So like in this pyramid here, the lateral area would just be the area of all the triangular sides, but not this bottom part. So in a cone, it's sort of the top pointy part and not the circle. So we're essentially excluding the circle from the surface area. So the lateral area of the cone is just pi RL. And then because we're only doing half of a sphere, the regular sphere formula is 4 pi r squared, but then because we're only doing half of it, we're going to divide by 2. So once again, we don't know what the lateral area, or I'm sorry, the slant height, not lateral area. We don't know what the slant height is, and so we need to do Pythagorean Theorem again for that. This is given as a diameter, and so that's 18, and so from there, we have to cut that in half. So the height and the diameter will always meet in the middle, and so that kind of gets cut in half as 9. Half of 18 is 9. So now when I do Pythagorean Theorem here, 9 squared plus 26 squared gives me the slant height, and then that, we're going to get a weird decimal here. I think we get 27.5. And so for this, we're just going to multiply these together, add it to 4 times pi times r squared, divide that by 2, and when we add both these pieces together, that gives us a total surface area of 1,285.83 centimeters squared, again because we're doing surface area. Alright, that is it for surface area. Thank you for watching. I know it, and now you know it.